Environmental Sciences. Paper O3 Biodiversity and Conservation Module 30 Wasteland. 1. Introduction. Land is the most precious resource on this planet Earth which supports life. Land is the natural home of most of species of plants, animals, microbes, etc. The primary sources of food for the lives on land come from the plants growing naturally of specifically grown for the purpose. With advancement humans and technology, domestication of plants in the form of agriculture started. The agriculture products now provide the raw materials for most of the human needs. The land available on the earth is not uniform and differs geologically, geographically, environmentally, climatically, etc. The different land masses on the different parts of the earth have been created through different geological processes and differ in their physical, chemical, geological composition, etc. Depending on the soil composition, fertility, availability of water, climatic and adaptive conditions, specific adaptations, different landforms support different type of vegetation. However, all the landforms do not naturally support vegetation or life productive due to climatic and adaptive conditions. But many landforms which were naturally productive have become unproductive due to various anthropogenic activities. The unproductive lands, whether natural or anthropogenic, are in general called wastelands. Such unproductive land or wastelands formed due to anthropogenic activities are of particular concern as the decreasing productive land area decreases the agricultural and vegetative productivity. Further, the ever-increasing human population adds woes to their survival due to decrease in productive land forms. Hence, it is necessary to manage and reclaim the wastelands to productive land forms. The present module discusses the definition of wasteland, their types, causes of formation and methods of their reclamation. 2. What is a wasteland? In general, the barren or degraded lands which do not fulfill their life-sustaining potential. Some of agricultural fields degraded or unfit for profitable cultivation are also often considered as wastelands. The most commonly used definition of wastelands is any type of land which because of neglect, overuse or degradation by climatic and/or anthropogenic factors is not being used to its fullest potential. Environmental Sciences. Paper O3 Biodiversity and Conservation Module 30 Wasteland. The National Wasteland Development Board, Government of India defines wasteland as land which is presently degraded and is lying unutilized except current fallow due to different constraints. 3. Types of wasteland. The wastelands can be mainly divided into two types and then subdivided into several subtypes. These are cultivable wastelands. These are the wastelands which can be cultured easily or without much difficulty. No special measures are required for their reclamation. These may reclaim at their own naturally with time. Non-culturable wastelands. These cannot be reclaimed easily and natural reclamation of is not possible. These can either be reclaimed with extreme difficulty or cannot be reclaimed at all. Types of wasteland. Culturable wastelands, non-culturable wastelands. Gullied or ravenous wasteland. Steep sloping area, undulating uplands. Waterlogged or marshy lands. Salt-affected lands. Degraded forest land. Shifting cultivation area. Degraded pastures, grazing lands. Mining, industrial wasteland. Land with or without scrub vegetation. Degraded land under plantation crops. Barren rocky area. Steep sloping area, snow-covered or glacial areas. Further subtypes of culturable and non-culturable wastelands are discussed below. Culturable wastelands. Environmental Sciences. Paper O3 Biodiversity and Conservation Module 30 Wasteland. Gullied or ravenous wasteland. This type of land is formed as a result of concentrated runoff flowing at very high speed. This runoff erodes soil and forms gullies. Fertility of these soils is very low and nearly at zero level. Steep sloping area, undulating uplands. Lands having slope from 3 to 10 degrees. These are unsuitable for cultivation due to high degree of slope which hinders in agricultural operations. These are characterized by accelerated water and wind erosion. The common vegetation present is weeds, grasses and bushes cover. Waterlogged or marshy lands. These lands remain submerged in water practically for whole of the year. These lands may develop due to seepage of water from rivers, canals or water reservoirs. These lands are formed near coastal and in other low-lying areas. Salt-affected lands. These lands have deposition of salts on the upper layers of soil. The depth of layer depends on the quantity of salts deposited. The salts deposited may be soluble or exchangeable. When there is excessive soluble salts and pH 8.5, soil is known as saline. When there is exchangeable Na, pH is from 8 to 10, soil is known as alkaline. These soils are usually fine-textured, light with good porous space but low. Salt-affected lands, waterlogged or marshy lands. Environmental Sciences. Paper O3 Biodiversity and Conservation Module 30 Wasteland. Water holding capacity. Due to deposition of salts, colors of upper crust vary from white to grayish white. Degraded forest land. Due to removal of forests for fuel and firewood, the tree canopy has been reduced and trees almost look like bushes or merely skeleton and they are not able to grow further. The soil of this area is good for planting crops provided used with care. Shifting cultivation area. The land areas are cleared by burning or cutting mostly by tribal people. This type of cultivation is also called jumming cultivation. The land is exposed to natural conditions of weathering till plant or crop sowing. The cultivation is done for few years, and then these tribal people move to another place and again clear other forest area for next cultivation and so on. This practice may lead to the formation of wastelands. Degraded pastures, grazing lands. These are the areas under permanent grasses where cattle or animals graze. These lands are initially degraded due to overgrazing by animals. Further, trampling of land by the animals loosen the upper soil layers which promote soil erosion by water or wind. These lands should be used with care as these are fertile and good in texture. Degraded forest land, shifting cultivation area. Pastures, grazing lands, mining, industrial wasteland. Environmental Sciences. Paper O3 Biodiversity and Conservation Module 30 Wasteland. Mining industrial wasteland. The land becomes barren to large extent due to excavations and movement of heavy machinery. This area is left exposed to natural weathering processes and it may lead to soil erosion due to wind and water. The remains of rocks and excavated waste material comes down with rains and wind to low-lying area and gets deposited there, creating more wastelands. These lands are mostly found in Jharkhand, Chhattisgarh, Bihar, Orissa, Madhya Pradesh, Karnataka, etc. Land with or without scrub vegetation. Scrub vegetation is generally used for vegetation dominated by stunted trees or bushes and the crown cover less than 10% of land area. These plants are neither eaten by animals nor used by man. Scrub vegetation degrades soil quality. The barren land which does not have any capability to grow vegetation or the fallow land covered with grass is called land without scrub. These lands are productive and can be used for agricultural purposes if managed properly. Degraded land under plantation crops. The plantation crops are grown for commercial purposes. The monoculture agriculture makes the soils deficient in specific nutrients which lowers the soil fertility. The continuous monoculturing degrades the soil and the fertile land becomes a wasteland. Non-culturable wasteland. These cannot be reclaimed easily. Natural reclamation of such wastelands is not possible. It can either be reclaimed with extreme difficulty or cannot be reclaimed at all. It can further be subdivided into following types. Land with scrub vegetation. Degraded land under plantation crops. Environmental sciences. Paper O3 Biodiversity and Conservation Module 30 Wasteland. Sandy area. Barren rocky area. Snow or glacial areas. Barren rocky area. Presence of big and small rocks hinders agricultural operations. Small rocks can be removed easily and the land can be used for raising crops. Where removal of big rocks is not possible, trees can be planted. Sandy area. Found in desert, coastal areas, near riverbeds and seashores. Sand deposits may found in a layer of 10-15 centimeters on the surface of soil or the area can be totally sandy. High wind currents form sand dunes which hinders cultivation. Snow-covered or glacial areas. Area remains practically under snow cover for whole of the year. Usually found in mountains with slope which may be too much for correction. Not suitable for agriculture. 4. Causes of wasteland formation. The main causes of wasteland formation are soil erosion due to high-speed wind and water, salinization, alkalization, inundation of land areas, natural factors like tsunami, floods and tidal actions, anthropogenic activities like improper agricultural practices in terms of excessive usage fertilizers, pesticides, monocropping, improper disposal of industrial waste, illegal and indiscriminate mining of minerals, jumping cultivation, etc. Climate change and environmental conditions like changing rainfall pattern, arid, semi-arid conditions. Management constraints. 5. Importance of wastelands. Need for wasteland reclamation. Provides the source of income for rural people. Help in maintaining an ecological balance in area. Maintains the local climatic conditions. Ensures a constant supply of fuel, fodder and timber for local use. Environmental sciences. Paper O3 Biodiversity and Conservation Module 30 Wasteland. Improves the soil fertility. 6. Wasteland reclamation. It is the process of turning barren, sterile land into fertile land suitable for agriculture or vegetation and cultivation. Reclamation means recovering physical structure of land to rebuild the ecosystem. These lands can be reclaimed by 3 methods. I. Topography and soil management. E. Water management. E. Crop management. I. Soil management. The soil management can be done with following. Filling of gullies and leveling. This can be done by filling stones in gullies, followed by compacting after placing soil over it. The leveling of land should be done to reduce water erosion. Further changing course of water or small check dams are also useful for the purpose. Planting grasses and bushes along the water course also help to stop soil erosion. Terracing. In this the earth is shaped in the form of small level terraces to hold soil and water. The terraces are given inward slope to increase infiltration of water. The banks of terraces are made firm and compact by placing stones and planting grasses over the sides. Scraping. This technique is used for soils covered with 2 to 3 cm thick layer of salts over it. This layer can be removed by scraping using spade. This is possible only at small scale and may not be possible at large scale. Flushing. The method is used for lands where water-soluble salts accumulate over land surface due to evaporation of water. To remove these salts, the area is first filled with water and allowed to remain there for few days. The water is checked for its conductivity so as to find that how much salts have dissolved. E. Crop management. I. Soil management. The soil management can be done with following. Filling of gullies and leveling. This can be done by filling stones in gullies, followed by compacting after placing soil over it. The leveling of land should be done to reduce water erosion. Further changing course of water or small check dams are also useful for the purpose. Planting grasses and bushes along the water course also help to stop soil erosion. Terracing. In this the earth is shaped in the form of small level terraces to hold soil and water. The terraces are given inward slope to increase infiltration of water. The banks of terraces are made firm and compact by placing stones and planting grasses over the sides. Scraping. This technique is used for soils covered with 2 to 3 cm thick layer of salts over it. This layer can be removed by scraping using spade. This is possible only at small scale and may not be possible at large scale. Flushing. The method is used for lands where water-soluble salts accumulate over land surface due to evaporation of water. To remove these salts, the area is first filled with water and allowed to remain there for few days. The water is checked for its conductivity so as to find that how much salts have dissolved. The water is then flushed off. Water should not be made to stand for long as salts can leach down to the subsoil. Deep plowing. Fallow lands, i.e. land that is normally used for farming but that is left with no crops for long time, become hard due to trampling by animals, settling of soil particles and lack of vegetation. To recover such lands, plowing should be done. Environmental sciences. Paper O3 Biodiversity and Conservation Module 30 Wasteland. Deep so that soil is open to absorb moisture from rain. This also removes weeds, stones and pebbles, etc. Drainage. Waterlogged soils are improved by this method. There are two types of drainage systems, subsurface drainage and underground drainage. Addition of green manure and soil amendments. The method is used to reclaim the soils low in organic matter, nutrients and alkaline or acidic in nature. In this method legume crops or nitrogen-fixing plants are cropped on the land and plowed down in the soil when they are soft and without flowers. They fix atmospheric nitrogen and add organic matter to soil. The chemicals like calcium carbonate, gypsum, fly ash and farmyard manure are added to the soil to increase the nutrient level and lime is added to reduce the soil acidity. Wind breaks. The method is used in areas having loose dry sandy soil and high intensity of speedy winds leading to movement of soil with wind. To reduce soil erosion due to high-speed wind, row of fast-growing trees are planted on boundaries of wastelands and banks of water courses. The tree species commonly used as windbreaks are poplar, neem, shesham bamboo and some fruit trees like beer, jamun mango etc. Silt trapping dams. When the water flowing from uplands cause soil erosion and siltation, to check the movement of eroded soil, big or small dams of reasonable height can be constructed against the course of water flow. Water is made to stand near these traps for a while and silt particles settle down, thus reducing soil erosion. Contour furrowing and bunding. The method is adopted for sloppy wasteland. The contours or furrows are made to allow water to remain in contour or to move at a slow speed and hence reduce soil erosion by water. This increases infiltration of water leading to water conservation. Mulching. The method is used to conserve soil moisture during droughts and when there are no rains. Mulches of dry grass, polythene, chemical mulch etc. are used to cover the soil surface. Mulching also checks soil erosion and suppresses emergence of weeds. Water management consists 3 options. Environmental sciences. Paper O3 Biodiversity and Conservation Module 30 Wasteland. Addition of water irrigation. Conservation of water protection. Removal of excessive water drainage. Addition of water irrigation. The addition of water to agriculture of vegetation is called irrigation. Irrigation or soil moisture is most important to provide water to the plants and maintain land productivity. Various methods are used for irrigation depending on the soil type, crop vegetation type, water availability etc. Mainly following techniques are used for irrigation. Furrow or channel used where land is leveled and water is in plenty. Flooding water is allowed to flow over the field. It is used where water is in plenty. Sprinkler, used where less but frequent water is required. It is very useful as no soil erosion, no loss of nutrients and water saving. Ring or basin method used for irrigating fruit and other trees. Individual tree is given water at a time. No loss of nutrients, no soil erosion but time consuming and laborious method. Drip irrigation, trickle irrigation method. This is relatively modern irrigation technology. In this, water is made to trickle down near root zone. Trickling of water drops is slow, underground and continues. There is no runoff of water, evaporation loss, no leaching down of water. Conservation of soil moisture. It includes all the policies, strategies and activities to sustainably manage and conserve the soil moisture. It can be conserved by already discussed methods of terracing, mulching, wind barriers, silt trapping dams etc. Some other methods used for the purpose are graded bunds. These are simple earthen embankments constructed across the slope contour of the area are called contour bunds. When these are constructed at predetermined longitudinal grade, they are known as graded bunds. These are constructed where rainfall is more than 600 millimeters per year. The runoff from upper bund is retained in the lower bund and again the surplus water passed on to the next bund and in this way water is conserved in the soil. Environmental sciences. Paper O3 Biodiversity and Conservation Module 30 Wasteland. Water storage in ditch during rainy season. Water is collected in ditches made at regular intervals depending upon soil type and amount of water to be handled. The water stored in ditches and can be used during water scarcity. Evaporation losses are overcome by covering the top of ditches. Drainage. This is the method of removal of excessive water from soil, subsoil. The most common method used is pumping out the water with mechanical methods. On sloppy lands channels are laid down and water flows down by gravity. Crop management. Growing suitable crops and their management is another approach to reclaim wasteland. Those crops selected for wastelands should have characteristics like drought tolerant, minimum rate of transpiration, less nutrient requirement etc. Growing leguminous crops and plowing them young in the soil. Multiple cropping, mixed cropping and crop rotation is done. Aonla and Jatropha plantations. The Aonla, commonly called Amla, is a minor subtropical deciduous tree. It can withstand drought conditions and can grow in neglected regions owing to its hardy nature. The fruit of the tree is in high demand due to its nutritional values. Similarly, another plant preferred to reclaim wastelands is Jatropha. It can grow on degraded soil and can resist drought conditions. The seeds have high oil content which can be used for biodiesel production. Fuel wood plantations on wastelands. The land which cannot use for agricultural purposes can be planted with fast-growing species of trees having rotation cycle of 4 to 7 years. It can provide fuel wood and fodder for cattle. Hence, it reduces excessive pressure on pasture lands. 7. Wasteland Indian scenario. India is a country having wide variation in geography, geology and climatology from north, south and east, west. On extreme north are located snow mountainous deserts with cold climate while southern region is dominated by oceans and maritime climate. On the east side are dry deserts and the west side is covered by the Himalayan hills. Hence, the lands in India have also very wide variety. India has only 2.4% of the world's geographical area but supports over 16% of the world's population. Further, India has only 0.5% of the world's grazing lands but supports over 18% of world's cattle. Environmental sciences. Paper O3 Biodiversity and Conservation Module 30 Wasteland. Population. This tremendous pressure on land due to ever-increasing human and domesticated animal population has led to conversion of productive lands into wastelands. Deserts, ravines, snow-clad areas and uncultivable land are among wasteland that abounds across states. Different agencies have made different assessments regarding wastelands in India. The difference is mainly due to use of different methodologies for estimation, changes with time period, use of different wasteland classification systems, etc. Some of the estimates are as follow. National Commission on Agriculture 148 mHa, NBSS and LUP estimates projected in 1994 187 mHa, NBSS and LUP estimates projected in 1994 and 2004 147 mHa, National Wasteland Development Board 123 mHa, Ministry of Rural Development and NRSA, 2063.85 mHa. Table 1. Wasteland Classification Scheme in India. Source: Wastelands Atlas of India, 2010. In order to accurately monitor the wastelands in India, Department of Land Resources, Government of India, in collaboration with NRSC, Department of Space initiated a project titled National Wastelands Monitoring Project (NWMP) and has published document Wastelands Atlas of India, 2010. In 2008, a harmonization exercise was taken up jointly by ICAR and NRSC, and a practical and management responsive estimate of wastelands degraded lands was. Environmental Sciences. Paper 03 Biodiversity and Conservation Module 30 Wasteland. Arrived at. The uniform classification system adopted by these agencies is enlisted in Table 1. Some of the facts of wastelands in India as per the Wastelands Atlas of India, 2010, are: total geographical area of India is 329 mHa. An estimated 47.22 mHa have been found to be under wastelands in 2006, which is 14.91% of the total geographical area of the country. Jammu and Kashmir has more than 50% of its area under wastelands. Himachal Pradesh and Sikkim that have wastelands ranging between 40 to 50%. States viz. Uttarakhand, Rajasthan, Nagaland, Manipur and Mizoram have wastelands ranging between 20 to 40%. Meghalaya occupy only 15 to 20% wastelands. 9 states that accounted for the extent of wastelands ranging between 10 to 15%. 8 other states have wastelands ranging between 5 to 10%. 3 states and union territories have less than 5% area under wastelands. The Wastelands Atlas of India, 2011, updated the data regarding wastelands in India in 2008-09 and compared it with data of 2005-06 published in Wastelands Atlas of India, 2010. The methodology and classification system used were similar to Wastelands Atlas of India, 2010. Some of the important facts of Wastelands Atlas of India, 2011 are: about 32,000 sq.km of wasteland has undergone a positive change in the entire country during the period, by getting converted into non-wasteland. The declining trend was observed in 21 states of the country. Majority of the change areas have been found in the states of Rajasthan, Mizoram, Manipur, Gujarat, Bihar, Karnataka, Andhra Pradesh and Uttar Pradesh. Increase in total wasteland area was recorded in 8 states, where non-wasteland has been observed to have changed into wasteland, bringing down the net decrease in wastelands during 2008-09 to about 0.17%, compared to 2005-06. The map 1 and 2 show the status of wastelands and change in wasteland status in 2008-09 compared to 2005-06. Environmental Sciences. Paper 03 Biodiversity and Conservation Module 30 Wasteland. Map -1. Environmental Sciences. Paper 03 Biodiversity and Conservation Module 30 Wasteland. Map 2. Source: Wastelands Atlas of India, 2011, by Department of Land Resources, Ministry of Rural Development, and National Remote Sensing Center, Indian Space Research Organisation, Department of Space, Government of India. Paper 03 Biodiversity and Conservation. Some data about the same Conclusion. Due to large number of anthropogenic and natural activities, the land degradation has increased. In order to support the ever-increasing population of humans and domesticated animals, there is utmost need to reclaim the wastelands. Programs are being run by different countries to reclaim the wasteland, and some of these have shown positive results. The mapping of wastelands after regular intervals is necessary to keep an eye on their status. Paper 1. Introduction. Desertification is a long process of land degradation, mostly due to climatic changes and human activities. This is an emerging problem faced by almost every country of the world. This is threat for ecological system and human survival. There are many factors responsible for the degradation of the land, which if continued for long time ultimately leads to formation of deserts. There are 2 types of causes of desertification, like direct and indirect. Direct causes include the climate of place and human activities like overexploitation, deforestation, overgrazing and improper use of irrigation technology. Indirect causes involve the poverty, population pressure, urbanization and unfair sharing of resources. 1/3 of world land is arid or semi-arid and affects the 250 million people. It has been predicted that due to increase in global warming, the area under desert will increase up to 17% by end of this century. The figure 1 shows the area under desert, vulnerable and invulnerable area on globe. Figure 1 represents area under the desertification. Source: desertification not only causes deterioration of environment, but also increase poverty among the local people. About 32% area of India is affected by land degradation and 25% geographical area is affected by desertification. Total area already under land degradation is 105.48 MHA and 81.45 MHA. Land area of country is undergoing the process of desertification. Dry lands cover a very huge area from the border in the northwest through the peninsula to the southern side of India. Major parts of Rajasthan, Gujarat, Haryana and southern Punjab. Paper 03 Biodiversity and Conservation. and small portion of Andhra Pradesh, Karnataka and Maharashtra come under hot arid regions. The 12 western districts of Rajasthan fall within the hot arid zone. Great Indian Desert, also known as Thar Desert, comes under this belt. This hot arid region suffers ample of problems such as low rainfall, droughts, intense heat and high evaporation. There is drastic climate change which is responsible for land infertility and ecological system destruction by desertification. Developing countries are facing large problem due to land degradation of useful land to meet the demands of increasing population. 2. Types of desert. There are various factors like location, climate, ground cover etc. are responsible for the desertification. If talk about the deserts, the main idea comes in mind is that the deserts are hot, but this not true. There are also cold, coastal and semi-arid deserts. Figure 2. The deserts of world are divided into 4 main types. A. Hot deserts. B. Coastal deserts. C. Semi-arid deserts. D. Cold deserts. Table 1. Deserts of world. Hot deserts, coastal deserts, semi-arid deserts. Cold deserts. Sahara, Thar, Namib, Great Basin, Arctic, Gibson, Sturt, Stony, Atacama, Colorado Plateau. Antarctic. Arabian, Tanami, Patagonian, Kalahari, Sonoran, Karakum, Mojave, Chilhuahuan, Gobi, Great Sandy, Simpson, Kilcom, Great Victoria, Taklamakan. Paper 03 Biodiversity and Conservation. Figure 2. Different types of deserts on world map. A. Hot deserts. These are located near to the Paper 03 Biodiversity and Conservation. And small portion of on Paper 03 Biodiversity and Conservation. Figure 2. Different types of deserts on world map. A. Hot deserts. These are located near to the equator. The temperature during daytime is very high, 40 to 45 C, and nights are relatively cold. In hot deserts, there is no cloud cover and it allows them to heat up and cool down quickly. Sahara is the world's largest desert located in the northern Africa and covers area of 3.5 million square miles. The plants growing in this area have no or very small leaves and only grow after the rainfall. The plants growing in the area are called succulent or xerophytic plants. The lack of leaves helps in reduction in water loss during transpiration, and leafless plants conduct photosynthesis through the green stems. Main plants of the area are different types of cactus. Figure 3a, elephant tree, desert sage and saguaro. Nocturnal animals are found in this area. They are called nocturnal because they stay inactive during day and come out for activities at night when desert become cooler. These animals make burrows to escape the heat. Kangaroo rat is the best example to hot desert animals. Figure 3b. Other animals are lizards, owls, jackals, snakes and scorpions. Paper 03 Biodiversity and Conservation. Figure 3. A cactus plant. B. Kangaroo rat. Table 2. Hot deserts of world. Hot deserts of the world. Name, location, size, plants, animals, physical characteristics. Arabian Peninsula. 2,300,000 square kilometers. Salt bush and acacia. Dromedary camel, gazelle, lizard, and jackal. Sandy area and most extensive stretches of sand dunes are present. Australia, 2,300,000 square kilometers. Spinifex. Grassalpus H. and Casuarina tree. Kangaroo, fat-tailed mouse, marsupial mole, rabbit-eared bandicoot, Spinifex hopping mouse, and Thrinny devil. Covered by sand and gravels. Chihuahuan. North. Central Mexico and Southwest United States. 455,000 square kilometers. Cacti, creosote, bush, lechubia, and mesquite. Javelina. Diamondback rattlesnake. Kangaroo and rat, roadrunner. High plateau covered by stony areas and sandy soil. Kalahari, Southwestern Africa. 520,000 square kilometers. Aloe and acacia. Jackal, gazelle, gerbil, ground squirrel, and hyena covered by sand dunes and gravel plains. Mojave, Arizona, California. 65,000 square kilometers. Verbena, Joshua tree, creosote, bush. Bighorn sheep, coyote, jackrabbit and zebra-tailed lizard covered by sandy soil. Bighorn sheep, coyote, jackrabbit and zebra-tailed lizard covered by sandy soil, salt flats and gravelly pavement. Paper 03 Biodiversity and Conservation. And desert. Sand. Monte, Argentina, 325,000 square kilometers. Creosote bush and cardon. Cactus. Cabbie, armadillo, jaguarundi, puma, and tuco. Covered by sand and soil. Sahara, Northern Africa. 9,100,000 square kilometers. Grasses. Tamarisks and acacia. Fennec fox, horned viper, jerboa, jackal, sand grouse and spiny-eyed lizard. Covered by mountains, rocky areas, gravel plains, salt flats, huge areas of dunes. Sonoran, Arizona 312,000 square kilometers. Desert mariposa. Lily, agave. Coulters. Globomalo. And creosote. Bush. Owl, Gila monster, kangaroo rat, pack rat, roadrunner and sidewinder. Covered by sand, soil, and gravelly pavement. Thar, India and Pakistan. 200,000 square kilometers. Euphorbias, acacia. Grasses. And shrubs. Dromedary camel, black buck, great Indian bustard, Indian spiny-tailed lizard and jackal. Majority of desert covered by sand dunes and rest covered by gravel plains. B. Cold desert. These are also known as polar deserts and found far from equator, located in the centers of continents and are high mountainous areas. During winter seasons, these are covered with snow and ice. South Antarctica and Argentina are examples of extreme cold desert. The main flora of cold desert are deciduous plants having spiny leaves and height between 15,122 centimeters, such as Nothofagus pumilio, Deschampsia antarctica, Colobanthus quitensis, etc. Mostly spadefoot toad is found in this area and during the hot dry spells covers itself with a substance or enters underground burrow to stay moist. It comes outside during heavy rainfall. For mating and laying eggs come in the temporary pools and toads return to burrows until the next heavy rains. Paper 03 Biodiversity and Conservation. Figure 4. A Nothofagus pumilio plant. B. Spadefoot toad. Table 3. Cold deserts of world. Cold deserts of the world. Name, location, size, plants, animals, physical features. Atacama coasts of Peru and Chile. 140,000 square kilometers. Cardon cactus, tamaruga trees and bunchgrass. Peruvian fox, lizards, llama and seabirds. Sand dunes and pebbles are present. Gobi, northern China and southern Mongolia. 1,200,000 square kilometers. Camel's thorn, grasses. Bamel, Bactrian, gazelle, jerboa and onager. Covered by sandy soil and small stones. Great Basin, Idaho, Nevada, and Oregon. 411,000 square kilometers. Sagebrush. And greasewood jackrabbit. Bighorn sheep, pocket mouse and blotched lizard covered by sand, gravel, and clay. Paper 03 Biodiversity and Conservation. Iranian, Iran. Afghanistan. And Pakistan. 390,000 square kilometers. Pistachio trees, shrubs and grasses. Onager, monitor lizard, oryx and scorpion. Covered by coarse gray soil, stony and salt flats. Namib coasts of southwest Ern, Africa. 135,000 square kilometers. Bunchgrass, aloe and Velvicia golden mole, darkling beetle, fringe toad. Lizard. Sidewinder and viper. Covered by sand dunes along the coast and gravel. Taklamakan, western China. 1,600,000 km2. Grasses, shrubs. Jerboa, Bactrian camel and gazelle. Covered by sand dunes and rocky soil. Turkestan, parts of the middle east and southwest Ern, Russia. 559,000 kilometers. To Saxal tree, alhagi shrub. And sedges. Saiga antelope, desert tortoise and gazelle. Covered mostly by extensive stretches of sand dunes. Coastal deserts by the sea. Water never evaporates from a cold ocean as quickly as it does when water is warm. Air blown onto the coast from a cold ocean contains no moisture to fall as rain. During the day, water evaporates from the land and is responsible for the desertification. Namib and Atacama are well-known coastal deserts. Coastal desert plants have thick and fleshy leaf and stem, can absorb large quantities for future use. Buckwheat bush figure 5a and saltbush are well-known plants of this area. Mainly owls, toads, lizards, coyotes figure 5b and snakes are found. Paper 03 Biodiversity and Conservation. Figure 5. A buckwheat bush plant. B. Coyotes. Semi-arid deserts. These receive the rainfall between the 250 mm and 350 mm and summers are long and dry with moderate temperature between 20 C and 30 C. 1/3 of Australia is the semi-arid desert. In these deserts, 3 types of plants are present, such thorny, hairy and waxy. Desert plants store their water in spongy tissue and animals try to eat, but thorns protect these plants from animals. Hairs protect plants from sunlight to reduce evaporation. In waxy plants, wax acts as the plastic wrapper to store the water inside. Prickly pear cactus figure 6a, old man cactus and aloe are usually found in this area. In semi-arid desert, jackrabbit figure 6b is found and uses the shadows of cactus and shrub to move one place to other. Figure 6. A prickly pear cactus. B. Jackrabbit. Hot desert in India. Thar desert is the hot and largest desert of India. It is located in the western Rajasthan and forms a natural boundary between India and Pakistan. It has the area. Paper 03 Biodiversity and Conservation. Of 77,000 square miles and includes the cities like Pushkar, Jaipur and Udaipur as well as many tourist spots including temples and forts. It covers the area of 0.32 million km2. During summers, temperature generally varies between 40 and 45 C and during night decreases to 20 to 29 C in this area. Rainfall is less than 400 mm rainfall, high temperature and strong winds with 1800 to 2200 mm of evapotranspiration responsible for negative water balance. Due to water problem, there is acute shortage of fodder, fuel, food and timber. The 682 plant species have been identified in the area, which includes 107 grasses. The 45 species of grasses are endangered plant species. Most common plant species in hot deserts are Prosopis cineraria, P. juliflora, Tecamella undulata, Acacia tortilis and many more. Cold desert in India. Cold desert is spread from Ladakh district of Jammu and Kashmir to Kinnaur district of Himachal Pradesh with area of 126,400 square kilometers. Indian cold desert bordered by the Great Himalayan and Inner Himalaya having extensive glaciers and snow fields. This area receives the less rainfall, 300 millimeters, in the form of snow and misty drizzles. Temperature in Claude Desert is in the range of -20 C to -40 C. Major area is under waste land and alpine shrubs or pastures and only 1-2% is cultivated land. Juniperus, Carragana, Artemisia, Lonicera, Potentilla, Myricaria, Ephedra, Salix, Rosa, and Rhododendron are cold desert plants. White Salt Desert of Kutch, also known as White Ran or Ran of Kutch, and it is one of dustiest and hottest regions of India. It is also expanded around the 2,898 square miles in Gujarat. This desert is covered with layers of white salt that gives the appearance of the snow. Average temperature during the summer can reach 50 C and in winter cools to below freezing. 3. Indicators of desertification of physical indicators. Drying of ground and surface water. Soil crust formation, compaction and decrease in soil depth. Decrease in soil organic matter and fertility. Formation of sandstorms, dune soil salinization or alkalinization. Paper O3 Biodiversity and conservation. Alteration in albedo, relative reflectance, of land. B. Biological indicators. Decrease in above-ground biomass, forest cover. Decrease in crop yield or decrease in crops. Alteration of key plant and animal species, changes in distribution and frequency of flora and fauna. C. Animal indicators. Change in population of domestic animals which leads to change in key species distribution and frequency. Decline in livestock production and herd composition. D. Social economic indicators. Change in population density. Increased resource competition due to change in land use, water use. Change in demographic parameters. Change in social indicators like increased poverty, decreased education, food habits, migration, dependence on cash crops. 4. Causes of desertification. 1. Unsustainable agrarian practices. These practices comprise of unnecessary and excessive use of fertilizers, pesticides, improper irrigation techniques, cropping patterns, unfit technologies, etc. are responsible for desertification. 2. Unsustainable water management practices. Inefficient irrigation practices, overpumping of groundwater particularly in the coastal regions resulting in saline incursion into aquifers, are some of major unsustainable water management practices which lead to desertification in such regions. Paper O3 Biodiversity and conservation. Three. Land use variation. With the rapid urbanization and industrialization, alteration of land from forestry and agriculture to other land uses has been one of the primary causes of land degradation. 4. Deforestation. It is hard to separate the causes from the effects of deforestation and forest degradation. Some direct causes of deforestation are land permissions for agriculture, including shifting cultivation, other land use changes including unplanned urbanization, land transfers, different forms of encroachments, overgrazing, uncontrolled and wasteful logging, illegal felling, and excessive fuel wood collection. 5. Unchecked discharge of industrial effluents into water bodies and soil. Industrial effluents and mining are also gradually emerging as important causes of desertification. In most cases, in the core of the problem is the mismanagement by land users and poor execution of pollution control regulations. Industrial effluents and their discharge into nearby water bodies and irrigation with poor quality water in many parts of the world are rendering stretches of land getting degraded. 6. Population pressure. The general problem of arid areas with large populations is essentially one of human ecology. The intrinsically limited resources within arid and semi-arid regions set the critical limit of production are finally dependent. 7. Lack of knowledge and awareness. There is inadequate quantitative data on current land use in arid and semi-arid regions of the country. Whatever information is available is scattered across many agencies and institutions and is not readily accessible to researchers, planners, and policymakers. Similarly, there is very little knowledge of land degradation and desertification issues among the general public, planners and policymakers, and even among those who are directly responsible for the management of land resources. 8. Climate change. It has great impact on desertification. The increase in global temperature and frequent conditions of drought escalates desertification. 9. Natural disasters. Sometimes natural disasters such as drought contribute to land damage. In such cases, there isn't a lot that we can do except work to try and help rehabilitate the land after it has already been damaged by nature. Paper O3 Biodiversity and conservation. 5. Effects of desertification. Farming becomes next to impossible. If an area becomes a desert, then it's become impossible to grow substantial crops there without special technologies. These technologies are very expensive, so that many farmers will have to sell their land to apply them or leave the desert areas. Hunger. Without farming in desert areas, the food that those farms produce will become much scarcer, and the people who live in those local areas will deal with hunger problems. Flooding. Without the plant life in an area, flooding is a lot more imminent. Not all deserts are dry. Those that are wet could experience a lot of flooding because there is nothing to stop the water from gathering and going all over the place. Flooding can also negatively affect the water supply, which we will discuss next. Poor water quality. When any area becomes a desert, the water quality is going to become a lot worse than it would have been otherwise. Drought. Due to deficiency of rain, number of droughts has been increased. Some seasonal and temporary droughts has been converted into permanent droughts so to change rain pattern and amount. Malnutrition. These droughts are further responsible for the decrease in the crop production that boosts the malnutrition problem. Death of animals. Animals start to die due to shortage of the water in desert area. In this whole ecosystem is disturbed to unbalancing among food chains and webs. Overpopulation. Desertification encourages animals and people to move to other areas where survival is easy. This causes gathering and overpopulation. Poverty. Poverty also plays a role in this aspect. Inadequate food and water compel the people to thrive. They devote a lot of time to gather the basic necessities of living. 6. Remedial measures. Agroforestry. It is a part of land use management in which tree or shrubs are grown around or among the lands those are at the edge of desertification to form more diverse, productive and ecologically rich. Paper 03 Biodiversity and Conservation. Sand dune stabilization. It is the best way to control the desertification by planting the vegetation on prone area to reduce the impact of the water and soil erosion. Shelter belt plantation. It is a technique in which tree and shrubs are planted in the rows to provide shelter from wind to reduce soil erosion. Minimum tillage. It is an ideal tool to protect the agricultural lands from the desertification. Minimum tillage is contrary to intensive tillage and soil conservation system like strip till with the goal of minimum disturbance with soil structure. Policy changes to other types of land use. The land which is used by public to get natural resources should be governed by the policies that are built to save the land. The policies should be changed as per the need and the type of land use. Education. Environmental education may impart the values of protecting our surroundings from damage. Awareness among farmers and society about sustainable methods of agriculture and land use may reduce desertification. Putting together rehabilitation efforts. Present advances in science and technology may help to rehabilitate the land that has already been pushed into desertification by putting together time and money. Sustainable practices. Sustainable practices provides plethora of remedial measures that can be applied to factors that cause desertification. 7. Program to combat desertification. The National Action Program to Combat Desertification. This program was submitted to UNCCD in 2001 and identifies the need to address and incorporate the following into integrated planning for sustainable development like natural resource management, socio-economic issue. This program focuses on water conservation and production systems. All approaches and strategies to combat desertification under UNCCD are described in this program. National Capacity Needs Self-Assessment. It was prepared in 2001 and suggested that India has capacity for meeting UNCCD obligations. Main purpose of this. Paper 03 Biodiversity and Conservation. Program was to address all causes of desertification and implementation of National Action Plan to combat the desertification. Mainstream of program was focused to work for lands those are not degraded by providing proper facilities to combating the desertification. Sustainable Land and Ecosystem Management (SLEM) program. It is a joint plan between the Government of India and Global Environmental Facility under the latter _S country partnership program under the GEF4 funding cycles. The objective of SLEM is to prevent and control of land degradation by restoration of degraded lands by biomass covering and harvesting in ways that maximize productivity as well as biodiversity conservation, carbon sequestration and sustainable use of natural resources. 8. Movements. Bishnoi movement. Amrita Devi from Marwar region of Rajasthan could not tolerate the destruction of the village's sacred trees and she hugged the trees to protect and encourage the others. She wanted to save sacred trees from the king's soldiers and 365 villagers were killed in this movement. Chipko movement. This movement was witnessed in Garhwal district of Uttarakhand during 1973 and Sundar Lal Bahuguna was the leader of this movement who enlightened the villagers by conveying the importance of trees in our environment. A woman of Advani village tied a sacred thread around the trees and hugged them, hence it is called Chipko movement or hug the tree movement. Apiko movement. It is also called southern version of Chipko movement and locally known as Apiko Chalubali. It started in Uttara Kannada and Shimoga districts of Karnataka in 1983 against the cutting and commercialization of natural forest and ruining of the livelihood. Conclusion. Desertification is a rising problem which is faced by the whole world. There are many alternatives tried and many are under process but these are not efficient to control the process of desertification. People awareness is also useless because human beings are selfish. And they do not bother about this situation and its seriousness. In future, there is needed to take strong actions in this field to control the desertification. Paper 03 Biodiversity and Conservation. 1. What are wetlands? Wetlands are neither just land nor just water, i.e. these are areas where water and land are mixed. They usually occur between dry land and deep water habitats. In other words, they are transitional zones between land and water where the flow of water, cycling of nutrients and energy of the sun produce a rich variety of plants and animals. Since these are transition zones, these support both aquatic and terrestrial species. The presence of shallow water creates environment that allow the growth of plants, hydrophytes, adapted to such conditions. These are considered the most productive ecosystems on the earth. These provide many important services to humans and environment. Wetlands can look very different throughout the world. Wetlands vary widely due to difference in climatic conditions, hydrology, water chemistry, soil types, topography, vegetation and other environmental factors. Wetlands are found through the globe from the tundra to the tropics. As per Millennium Ecosystem Assessment estimates, wetlands cover 7% of the Earth's surface and deliver 45% of the world's natural productivity and ecosystem services. However, the existence of these valuable resources is under threat due to anthropogenic activities and calls for need to preserve and conserve these resources. Pantanal is the largest wetland in the world situated in Brazil to South America and covers an area of 150,000 square kilometers. Wetlands have been defined differently by different agencies in the world. Some of the definitions are. Definition. According to most widespread definition, wetlands are defined as lands transitional between terrestrial and aquatic ecosystems where the water table is usually at or near the surface or the land is covered by shallow water. US EPA defines wetlands as areas where water covers the soil, or is present either at or near the surface of the soil all year or for varying periods of time during the year, including during the growing season. World Wildlife Organization defines wetland, a place where the land is covered by water, either salt, fresh or somewhere in between. Marshes and ponds, the edge of a lake or ocean, the delta at the mouth of a river, low-lying areas that frequently flood, all of these are wetlands. Paper O3 Biodiversity and Conservation. Ramsar Convention on Wetlands define wetlands as areas of marsh, fen, peatland or water, whether natural or artificial, permanent or temporary, with water that is static or flowing, fresh, brackish or salt, including areas of marine water the depth of which at low tide does not exceed 6 meters. 2. The Ramsar Convention. The Ramsar Convention, also known as the Convention on Wetlands, was adopted on the 2nd of February 1971 in Ramsar, Iran. It is an intergovernmental treaty which provides the framework for national action and international cooperation for the conservation and wise use of wetlands and their resources. As per this convention definition, most of the natural water bodies, such as rivers, lakes, coastal lagoons, mangroves, peatland, coral reefs, and man-made wetlands, such as ponds, farm ponds, irrigated fields, sacred groves, salt pans, reservoirs, gravel pits, sewage farms, and canals constitute the wetland ecosystem. The convention's mission is the conservation and wise use of wetlands by national action and international cooperation as a means to achieving sustainable development throughout the world. 2.1. Criteria for identifying wetlands of national importance. Broadly, the convention has 2 groups and 9 criteria for recognizing a wetland under this convention. Source: nbfor.nic.in/division/shurf/wwd_booklet.pdf. These are: Group A, sites containing representative, rare or unique wetland types. Criterion 1. It recognizes those sites of national, international importance which contains a representative, rare, or unique example of a natural or near-natural wetland type found within the appropriate biogeographic region. Group B. Sites of international importance for conserving biological diversity. Criteria based on species and ecological communities. Criterion 2. A wetland should be considered nationally important if it supports vulnerable, endangered, or critically endangered species or threatened ecological communities. Criterion 3. A wetland should be considered nationally important if it supports populations of plant and/or animal species important for maintaining the biological diversity of a particular biogeographic region. Paper O3 Biodiversity and Conservation. Criterion 4. A wetland should be considered nationally important if it supports plant and/or animal species at a critical stage in their life cycles, or provides refuge during adverse conditions. Specific criteria based on water birds. Criterion 5. A wetland should be considered nationally important if it regularly supports 20,000 or more water birds. Criterion 6. A wetland should be considered nationally important if it regularly supports 1% of the individuals in a population of one species or subspecies of water bird. Specific criteria based on fish. Criterion 7. A wetland should be considered nationally important if it supports a significant proportion of indigenous fish subspecies, species or families, life history stages, species interactions and/or populations that are representative of wetland benefits and/or values and thereby contributes to global biological diversity. Criterion 8. A wetland should be considered nationally important if it is an important source of food for fishes, spawning ground, nursery and/or migration path on which fish stalks, either within the wetland or elsewhere, depends. Specific criteria based on water, life and culture. Criterion 9. A wetland should be considered nationally important if it is an important source of food and water resource, increased possibilities for recreation and ecotourism, improved scenic values, educational opportunities, conservation of cultural heritage, historic or religious sites. 2.2. Advantages of joining Ramsar Convention. Provides access to financial aid for conservation of wetlands. Increased publicity of the site at the international level. Encourages international cooperation and increases availability of expert advice and latest information on site-related problems of wetland conservation and management. Provides an opportunity for learning the best global practices for wise use of wetlands. Opportunity for getting international guidelines on various wetland conservation themes. Paper O3 Biodiversity and Conservation. 2.3. Current status of the convention, as on February 2018, as per. It has been signed by 169 countries. It recognizes 2,331 wetland sites all over the world. It covers an area of nearly 225 million hectares. India has 26 wetlands of international importance. The Ramsar Convention Secretariat carries out the day-to-day coordination of the convention's activities. The Ramsar Convention Secretariat is located in Gland, Switzerland. World Wetlands Day is celebrated on 2nd February every year. 3. Characteristics common to all wetlands. Depth. The depth of the wetlands should not exceed 6 meters. Water. The top 12 inches of soil must be saturated with water for at least 15 days for an area to be classified as a wetland. Their sources of water may be surface water, ponds, lakes, streams, rivers, and oceans, or groundwater. The amount of water should be enough to support wetland vegetation. Soils. The soil is mostly hydric, because the spaces between soil particles are filled with water. Soils are anaerobic, i.e. the soil lacks oxygen. The color of wetland soils is usually dark brown to black due to the presence of mineral or organic matter. These soils may smell like rotten egg due to the presence of sulfur. Productivity. Wetlands are among the most productive ecosystems of the world, comparable to rainforests and coral reefs. They are also known as biological supermarkets. Vegetation. The vegetation specifically adapted to live in an area that is saturated with water and has reducing conditions as present, e.g. water lilies, arrowheads, duckweed, pondweeds, etc. Saltwater wetland plants have special adaptations that allow them to tolerate salt. Plants in wetland are called hydrophytes. Earth coverage. Wetlands are found from tundra to tropics and on every continent except Antarctica. They cover an area of about 570 million hectares, which accounts for 6% of the Earth's land surface. Paper O3 Biodiversity and Conservation. 4. Types of wetlands. The wetlands differ due to variations in soil, landscape, climate, water quality, vegetation, etc. The two general categories of wetlands are tidal or coastal wetlands. As the name suggests, these are found along the oceans and seacoasts where seawater mixes with fresh water, which includes estuaries. These type of wetlands are characterized by the fluctuating salty water levels, depend on tide action, and grassy vegetation that adapt to the saline conditions. Non-tidal or inland wetlands. These are wetlands either on floodplains along rivers, streams, lakes, ponds, etc. or low-lying areas where the groundwater comes out of soil surface or where rainfall sufficiently saturates the soil. Many of these wetlands are seasonal in nature. 4.1. Classification of wetlands. Broadly, two types of classification systems are used for wetlands. I. Hydrogeomorphic classification. E. Cowardin system. I. Hydrogeomorphic classification. This classification system was introduced by Brinson in 1993. This classification system is based on the concept of position in the landscape, their source of water, and the flow of water. The classification system recognizes 7 major classes, and further subdivided into subclasses. The following definitions are modification from Brinson et al., 1993 and Smith et al., 1995. Riverine. Wetlands within river and stream channels, i.e. lie adjacent to rivers and streams, are called riverine. These are characterized by flowing water having salinity less than 0.5 part per thousand. These are mostly found in floodplains and riparian corridors along the stream channels. The sources of water are overbank flow from channel or subsurface hydraulic water, interflow and return flow from adjacent uplands, tributary inflow and precipitation. B. Depressional. As the name indicates, these are located in topographic depressions where surface water from precipitation, and both interflow and overland flow from adjacent uplands can accumulate. These wetlands may lose water due to drainage from outlets, evapotranspiration and contribution to groundwater. Peat deposits may. Paper O3 Biodiversity and Conservation. Develop in these wetlands. The common example of depressional wetlands is prairie potholes. Seat slope. These normally occur on sloping land where there is a discharge of groundwater to the land surface. These are not capable of holding water for long as these do not have well-defined contours. The water sources are groundwater return flow, interflow from surrounding uplands and precipitation. The common example of slope wetlands is fens. D. Mineral soil flats. These occur in floodplain terraces, relic lake bottoms or interstream uplands and are primarily fed by precipitation. Their size varies significantly from 10 acres to thousands of acres. They can be distinguished from DEPRESSIONAL and slope wetlands as these do not receive any groundwater discharge. They lose water due to evapotranspiration, saturation overland flow, and groundwater seepage. Mineral soil flats that accumulate peat can eventually become the class organic soil flats. Pine flatwoods with hydric soils are a common example of mineral soil flat wetlands. E. Organic soil flats. These are also called extensive peatlands. These differ from mineral soil flats, in part, because their elevation and topography is controlled by vertical accretion of organic matter. They are located commonly on flat interfluves. These may also be found where depressions have been filled with peat to form a large flat surface. The sources of water are dominantly precipitation. The water loss is by saturation overland flow and groundwater seepage. The common examples of organic soil flat wetlands are portions of the Everglades and northern Minnesota peatlands. F. Estuarine fringe. Estuarine or tidal fringe wetlands are located between the open saltwater of the bays or gulf and the uplands of the coastal plain and barrier islands. These may be vegetated marshes or unvegetated mud and sand flats. These occur in strips of varying sizes from few feet to several miles wide. The dominant water sources are tidal currents and river flow and additional or groundwater discharge and precipitation. The common examples of estuarine fringe wetlands are Spartina alterniflora salt marshes. Paper O3 Biodiversity and Conservation. G. Lacustrine fring. These wetlands are located adjacent to lakes and may consist of a floating mat attached to land. The sources of water are elevation of the lake water, precipitation and groundwater discharge. Surface water flow is bidirectional and is controlled by water level fluctuations in the adjoining lake. These wetlands are nearly similar to depressional wetlands. These wetlands lose water by flow returning to the lake after flooding, groundwater seepage and evapotranspiration. The common example of lacustrine fring is E. wetlands unimpounded marshes bordering the Great Lakes. E. Cowardin system. The system of classification was developed by Lewis M. Cowardin et al. In 1979. This system of classification is based on 4 different factors. Types of vegetation present. Pattern of flooding. Chemistry of the water type of soil. On the basis of these factors, the wetlands have been classified into 5 major types. A. Marine wetland or coastal wetlands. These are areas exposed to the open ocean. These include coastal lagoons, rocky shores and coral reefs. B. Estuarine wetland. These are Paper O3 Biodiversity and Conservation. 4. Types of wetlands. The wetlands differ due to variations in soil, landscape, climate, water quality, vegetation, etc. The 2 general categories of wetlands are tidal or coastal wetlands. As the name suggests, these are found along the oceans and seacoasts where seawater mixes with fresh water, which includes estuaries. These type of wetlands are characterized by the fluctuating salty water levels, depend on tide action, and grassy vegetation that adapt to the saline conditions. Non-tidal or inland wetlands. These are wetlands either on floodplains along rivers, streams, lakes, ponds, etc. or low-lying areas where the groundwater comes out of soil surface or where rainfall sufficiently saturates the soil. Many of these wetlands are seasonal in nature. 4.1. Classification of wetlands. Broadly, two types of classification systems are used for wetlands. I. Hydrogeomorphic classification. E. Cowardin system. I. Hydrogeomorphic classification. This classification system was introduced by Brinson in 1993. This classification system is based on the concept of position in the landscape, their source of water, and the flow of water. The classification system recognizes 7 major classes, and further subdivided into subclasses. The following definitions are modification from Brinson et al., 1993 and Smith et al., 1995. Riverine. Wetlands within river and stream channels, i.e. lie adjacent to rivers and streams, are called riverine. These are characterized by flowing water having salinity less than 0.5 part per thousand. These are mostly found in floodplains and riparian corridors along the stream channels. The sources of water are overbank flow from channel or subsurface hydraulic water, interflow and return flow from adjacent uplands, tributary inflow and precipitation. B. Depressional. As the name indicates, these are located in topographic depressions where surface water from precipitation, and both interflow and overland flow from adjacent uplands can accumulate. These wetlands may lose water due to drainage from outlets, evapotranspiration and contribution to groundwater. Peat deposits may. Paper 03 Biodiversity and Conservation. Develop in these wetlands. The common example of depressional wetlands is prairie potholes. C. Slope. These normally occur on sloping land where there is a discharge of groundwater to the land surface. These are not capable of holding water for long as these do not have well-defined contours. The water sources are groundwater return flow, interflow from surrounding uplands and precipitation. The common example of slope wetlands is fens. D. Mineral soil flats. These occur in floodplain terraces, relic lake bottoms or interstream uplands and are primarily fed by precipitation. Their size varies significantly from 10 acres to thousands of acres. They can be distinguished from DEPRESSIONAL and slope wetlands as these do not receive any groundwater discharge. They lose water due to evapotranspiration, saturation overland flow, and groundwater seepage. Mineral soil flats that accumulate peat can eventually become the class organic soil flats. Pine flatwoods with hydric soils are a common example of mineral soil flat wetlands. E. Organic soil flats. These are also called extensive peatlands. These differ from mineral soil flats, in part, because their elevation and topography is controlled by vertical accretion of organic matter. They are located commonly on flat interfluves. These may also be found where depressions have been filled with peat to form a large flat surface. The sources of water are dominantly precipitation. The water loss is by saturation overland flow and groundwater seepage. The common examples of organic soil flat wetlands are portions of the Everglades and northern Minnesota peatlands. F. Estuarine fringe. Estuarine or tidal fringe wetlands are located between the open saltwater of the bays or gulf and the uplands of the coastal plain and barrier islands. These may be vegetated marshes or unvegetated mud and sand flats. These occur in strips of varying sizes from few feet to several miles wide. The dominant water sources are tidal currents and river flow and additional or groundwater discharge and precipitation. The common examples of estuarine fringe wetlands are Spartina alterniflora salt marshes. Paper 03 Biodiversity and Conservation. G. Lacustrine fring. These wetlands are located adjacent to lakes and may consist of a floating mat attached to land. The sources of water are elevation of the lake water, precipitation and groundwater discharge. Surface water flow is bidirectional and is controlled by water level fluctuations in the adjoining lake. These wetlands are nearly similar to depressional wetlands. These wetlands lose water by flow returning to the lake after flooding, groundwater seepage and evapotranspiration. The common example of lacustrine fring is E. wetlands unimpounded marshes bordering the Great Lakes. E. Cowardin system. The system of classification was developed by Lewis M. Cowardin et al. In 1979. This system of classification is based on 4 different factors. Types of vegetation present. Pattern of flooding. Chemistry of the water type of soil. On the basis of these factors, the wetlands have been classified into 5 major types. A. Marine wetland or coastal wetlands. These are areas exposed to the open ocean. These include coastal lagoons, rocky shores and coral reefs. B. Estuarine wetland. These are partially enclosed by land exposed to a mixture of fresh and salt water bodies of water. These include deltas, tidal marshes and mangrove swamps. C. Riverine wetlands. These include wetlands along rivers and streams. D. Lacustrine lake wetland. These are wetlands associated with the lakes. E. Palustrine wetlands. These are freshwater wetlands not associated with a river or lake. It means marshy, including marshes, swamps and bogs. In addition to these there are human-made wetlands such as fish and shrimp ponds, farm ponds, etc. Some common subtypes of wetlands are described below. Marshes. It is a wetland characterized by dominant herbaceous plants rather than woody plant species. These form a transition between the aquatic and terrestrial ecosystems and are located at the edges of lakes and streams. They are often dominated by grasses, rushes or reeds. These can be of many kinds ranging from the freshwater to saltwater, coastal to inland. Paper 03 Biodiversity and Conservation. Prairie potholes to the Everglades, etc. These are rich in nutrients and the pH is usually Paper 03 Biodiversity and Conservation. G. Lacustrine fring. These wetlands are located adjacent to lakes and may consist of a floating mat attached to land. The sources of water are elevation of the lake water, precipitation and groundwater discharge. Surface water flow is bidirectional and is controlled by water level fluctuations in the adjoining lake. These wetlands are nearly similar to depressional wetlands. These wetlands lose water by flow returning to the lake after flooding, groundwater seepage and evapotranspiration. The common example of lacustrine fring is wetlands unimpounded marshes bordering the Great Lakes. Cowardin system. The system of classification was developed by Lewis M. Cowardin et al. In 1979. This system of classification is based on 4 different factors. Types of vegetation present. Pattern of flooding. Chemistry of the water, type of soil. On the basis of these factors, the wetlands have been classified into 5 major types. A marine wetland or coastal wetlands. These are areas exposed to the open ocean. These include coastal lagoons, rocky shores and coral reefs. B. Estuarine wetland. These are partially enclosed by land exposed to a mixture of fresh and salt water bodies of water. These include deltas, tidal marshes and mangrove swamps. C. Riverine wetlands. These include wetlands along rivers and streams. D. Lacustrine lake wetland. These are wetlands associated with the lakes. E. Palustrine wetlands. These are freshwater wetlands not associated with a river or lake. It means marshy, including marshes, swamps and bogs. In addition to these, there are human-made wetlands such as fish and shrimp ponds, farm ponds, etc. Some common subtypes of wetlands are described below. Marshes. It is a wetland characterized by dominant herbaceous plants rather than woody plant species. These form a transition between the aquatic and terrestrial ecosystems and are located at the edges of lakes and streams. They are often dominated by grasses, rushes or reeds. These can be of many kinds ranging from the freshwater to saltwater, coastal to inland. Paper O3 Biodiversity and Conservation. Prairie potholes to the Everglades, etc. These are rich in nutrients and the pH is usually neutral. This supports wide variety of plant and animal life. Depending on the basis of their location and salinity, marshes can be subdivided as salt marshes, freshwater tidal marshes and freshwater marshes. These 3 further contains a different set of plants and animals. Saltwater marshes. These are marshes located close to the coastal shoreline where the motion of the tides affects them. These are mostly found in lagoons, estuaries, etc. The nutrients are absorbed from the water returning back after tides. These are dominated by salt-tolerant grasses, cord grass, spike grass and salt meadow rush, Juncus gerardi, and specially adapted rooted vegetation. Freshwater tidal marshes. They are mostly freshwater marshes occasionally affected by the ocean tides. Water levels in these wetlands generally vary from a few inches to 2 to 3 feet. The diversity of the plants and animals in these marshes is much higher than in salt marshes. Freshwater marshes. They frequently occur along the boundaries of lakes, ponds and rivers. These are poorly drained and some of these may periodically dry out completely. These are rich in organic matter and nutrients. The common plants and animals present are lily pads, cattails, reeds, bulrushes, and waterfowl, red-winged blackbirds, great blue herons, otters, muskrats, etc. The examples of these marshes are prairie potholes, playa lakes, vernal pools and wet meadows. Swamps. Swamps are forested wetlands dominated by woody plants and bushes. These are located near rivers or lakes and have mineral soil that drains very slowly. The soils in swamps may or may not be rich in nutrients. The swamps having highly organic soils form a thick, black, nutrient-rich environment for the growth of water-tolerant trees like cypress, Taxodium spp, Atlantic white cedar Chamaecyparis thioides, and Tupelo Nyssa aquatica. Other swamps are dominated by shrubs, such as buttonbush or smooth alder. These are rich in biodiversity and support variety of plants, birds, fish, and invertebrates such as freshwater shrimp, crayfish, and clams. These are also the habitat of many rare, endangered species, such as American crocodile. Swamps may be divided into shrub swamps and forested swamps depending on the type of vegetation present. These are further classified by the types of trees growing there. Paper O3 Biodiversity and Conservation. Further, it has been hypothesized that ancient swamps are a source of the fossil fuel coal. Coal is formed from plants which died and decayed in the absence of oxygen millions of years ago. The pressure of upper layers for million years caused the vegetation to harden, or fossilize into coal. Bogs. The bogs are freshwater wetlands which have soft spongy ground consisting mainly of partially decayed plant matter called peat mosses. The source of water is precipitation and hence do not receive nutrients from runoff and are low in nutrients. The water table is close to the ground surface. The dead plant matter makes sphagnum moss and wired due to oxygen-starved conditions. Hence, bogs become choked with living and decaying plants. These slowly decaying plants become the main components of the bog's soggy soil, called histosol, which supports the growth of fungi and low-lying shrubs, such as heather. Hence such bogs are often called heaths. Sometimes, a bog is entirely covered with the sphagnum moss which prevents precipitation from evaporating. Such bogs are called ombrotrophic bogs. They are characterized by spongy peat deposits, acidic waters and a floor covered by a thick carpet of sphagnum moss. Fens. These are peat-forming wetlands with low to moderate fertility and are fed by both groundwater and surface runoff. These receive the nutrients through drainage from surrounding mineral soils and from groundwater movement. These differ from bogs being less acidic and higher nutrient levels. Hence, these support a diverse plant and animal community. They share some of the features of low fertility bogs as well as higher fertility swamps. These wetlands are dominated by grasses, sedges, rushes and wildflowers. Some fens are characterized by parallel ridges of vegetation separated by less productive hollows. The deposition of peat over long time may separate the fen from its water supply and hence nutrients. This may ultimately be converted into a bog. 5. Importance of wetlands. Wetlands are very important for the ecological balance of the earth and human survival. The wetlands are among the world's most productive environments. They are cradles of biological diversity. They support a high concentration of birds, mammals, reptiles, amphibians and fish. Important storehouse of plant genetic material, e.g. rice. A wetland plant is a staple diet of more than half of humanity. Wetlands also support human settlements and Paper O3 Biodiversity and Conservation. Play important role in sustainability of resources. We need to save the wetlands due to their importance benefits for humans. The importance benefits of wetlands are as follow. Water quality. The wetlands act as filter of sediments, nutrients, pollutants, microorganisms, etc., which flow through water runoff from human settlement, roads, agriculture, industrial effluents. Hence these are called treatment wetlands. Such wetlands are even specifically constructed to improve surface water quality and to treat stormwater runoff. Flood control. Wetlands act as reservoirs of extra water and hence control the floods. This results in more gradual discharges of water over a longer period of time. This also protects the downstream property of owners from flood damage. Reduce erosion. One of important function of wetland is its ability to slow the